Before we begin talking about the normal distribution, I really want to try and make something extremely clear because this is going to be important all throughout Stats 213, all throughout Stats 217, and anytime you're ever talking about statistics, this is probably going to be important. Okay, basically the normal distribution is characterized by this really classic shape called the Bell distribution. It's because it looks like a bell. It's also called the Gaussian distribution because Carl Friedrich Gauss is the one who studied it first. And it's called the normal distribution because when things are normal, it acts this way. Okay, so we need to realize that there are different scales going on here. The middle, the center of this curve, of this symmetric curve, has a few different names. There are two different scales. Just like a weight scale could be telling you pounds, or it could be telling you kilograms. Still talking about the same amount of weight, just in different units. Okay, so there are different units that we talk about things here with the scale. So imagine something, because I brought it up, the example of weight. Let's say the normal weight, okay, normally distributed, the normal weight for a 19-year-old male is, I don't know, just for example, 180 pounds. Okay, that's the average weight. That would be in the center. Okay, so mu, or the average, would be 180 pounds. Okay, then if you had a standard deviation of, let's say, give or take 20 pounds, what you're saying is most adult males then are in between 180 is the average, 180 plus one standard deviation. If 20 was a standard deviation, so 180 plus 20 would be 200, and 180 subtract 20 would be 160. We're saying a large amount of adults are in between 160 pounds and 200 pounds. Okay, so in between, give and take one standard deviation away from the middle. Okay, of course you could do two standard deviations. So here 180 is the middle, plus 2 times 20, which is 40. Okay, so 180 plus 40 is going to be 220. Here, mu plus 2 standard deviations is 220. And you can continue going on this way. Okay, so that's one scale. I'm going to call it the X scale. Typically, it is the scale that is talking about the context of the thing that you're measuring. So here I'm talking about pounds. So here my scale is in pounds. I could have changed this all to be in kilograms. The same numbers similar numbers would apply, just they would be in kilograms instead. Okay, this would be in the context of what I measured. I measured pounds, and I'm talking about pounds. There is another scale called the standardized normal scale, and it's talking about z-scores. Okay, so anything can be standardized. Okay, instead of talking about the middle being 180, let's just pretend that middle point is 0. Every time so here, this point, which was 180 plus 20, or 200, what we could say is we are just one standard deviation, okay, 1 sigma away. So here we're positive 1 standard deviation away. Here we're negative 1 standard deviation away. Okay, so this is just z-score units, also called standard deviation units. Okay, so here you're talking about in context of however it is you measured pounds, kilograms, stones, whatever it is you measure weight with. Here I can just talk about a standardized notation, a z-score. Okay, how I get a z-score is I take whatever that value is. Here, for example, let's say the value is 200. If I subtract the mean, which would be 180, okay, so 200 minus 180 would be 20 on the numerator. And the standard deviation for this example I'm suggesting is 20. I'd have 20 divided by 20, and I would get 1. Okay, so here you can find the z-score and the x by this relationship. If I knew that the z-score was 2, I could put here where z is 2, 2 here times by a standard deviation. If I move this over here, 2 times 20 would be 40. And if I add, so if I'm subtracting the mu, I need to add it on this side. So 40 plus 180, which was the average, and I could convert into my x scale, which would be 220. What I need you to understand is that there are two scales going on when we're talking about the normal distribution. There's the scale in terms of the context in which you are measuring, and then there is the standard scale, also called the z-score.